Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at stacks and queues in C++. So I'm going to take these both together because they're very similar to each other. And I've included stack and queue at the top of this file. I've also created a little test class which just has one instance variable, a string called name, and I've given it a constructor to initialize name with. I've also created a destructor which I'm going to use a bit later to illustrate a point. And I've created a print method so that we can see what name the object has. Let's take stack first. So I can create a stack of my object like this, and you can also use, of course, primitive types. You can use whatever you like in a stack. Let's call this maybe, let's call it test stack, like that. So a stack is it's a last in first out structure. So a stack is called a stack by analogy with a stack or pile of objects in the real world. If you have a stack of plates, then you can add plates to the top of the stack. It's got a top, and you can remove them again. And the one that you remove is going to be the last one you added. They come off in the kind of in the reverse order that you added them. So the most recent one you added is going to be the one you remove first. So this makes it last in, first out. So there's a little acronym there, last in, first out. We've been using stacks without even realizing it in our programs, because there's an area of memory called the stack, which is used to store, for example, the values of local variables, and that works on a last in, first out basis. So stack is a concept that's a broad application in computer programming, and this is an implementation of a stack. Now, when we add items to the stack, we talk about pushing them onto the stack. So you could think, for example, of one of those machines that holds a deck of playing cards, and to add a card to the stack, you push it onto the top and the machine holds it. And then when you take the playing card off the top of the stack of cards, you just sort of pop it off. So we talk about pushing things onto the top of the stack, pushing it onto the stack, and popping them off the stack. So let's say test stack.push, and we'll create an object here, and we'll give it the name Mike. We'll have, let's have two more objects here, Mike, John, and Sue. Now to get at objects in that stack, there's no way to iterate through a stack or a queue. If you think you want to iterate through a stack, you don't need a stack. You need some other collection like a vector, or one of the ones that we're going to still look at in this section. But what we can do is we can look at the top of the stack. So we could say here, test. I'll go to the trouble of creating a variable here rather than just trying to access it directly. So let's say test1 equals test stack dot top. It's the top of the stack, and let's say test1 dot print, like this. So if we do this and we run it, so the one that's going to be on top of the stack, whoops, I've got to call it test1, is going to be the last object that we pushed onto the stack. So we get Sue. So that's the last one we added. Now we can pop values off the stack by saying test stack.pop, and that doesn't return anything, just returns void, has a void return type. And then if we look at the the top of the stack again, let's do this with test2 and test2.print. Now, since we popped Sue off the top of the stack, the next object that's now on top is going to be John here. Now, there's a little thing here that you have to be careful about. A lot of these collections, these standard template classes, they actually, when you access objects within the class, within the collection class, I'll call it. Well, in Java, we talk about collection classes because they're a collection of objects. So let's use that term here as well. We've got a collection of objects that's stored in this data structure somehow. And when we access them, usually the standard template class will return a reference to the object that's in it. So what we're actually doing here, let's say, is we are returning a reference to the object that's in the stack. And then because we've just used the equality operator with this object that we've declared here, we're actually copying the object that the reference refers to into this. So it's using a shallow copy here. It's using the default implementation of the assignment operator, the equals operator, and it's just copying the values of the instance variables into here. So that means that when we even add objects to the stack, like this in fact, we're going to be destroying the original object that we added. This isn't directly related to the return type, but it's a similar thing to be aware of, that when you add objects here, you're destroying the original if you do it like this, and then you're creating a copy of it within the stack. So it's going to be creating a shallow copy using the assignment operator equals. So we see objects are destroyed even as we're adding them here. Now, what I really wanted to show you was that this means that if you want to be really efficient, what you can do is you can get a reference here. So now we don't have to make a copy of the object anymore. What we're doing is we're returning a reference with top here, and we're just storing the value of that reference in here. So this now refers to, it's just a reference to the existing object that's already in the stack. And when you do pop, that object is removed and discarded. So if I were to do pop here and then call test1.print, this is very unreliable code. It might work. If we actually try it, it probably will seem to work. So we've got Sue here, which is the right object. But because we've popped it, it's actually been destroyed. And we can see that if we uncomment the text in the destructor here, we can see that when we actually, we're actually doing print here on test one, but before that, the object was destroyed. So maybe let's just put a cout here with Endler just to break this up visually a bit. So if we run this now, we can see we're destroying the objects that we originally added, 3 of them. It's coming out from here. And then when we do pop, we're destroying this Sue object here. We're destroying it there, but then we're still using this reference. And this is invalid code. It works by coincidence. So if you do get a reference to your object, you have to be aware that as soon as you pop that object off the stack, it's destroyed and the reference is invalidated. You can't rely on your program working anymore if you're trying to use that reference, a reference to an object that's been popped off the stack. So if you do want this object to hang around after you've popped it, you need to remove that reference and get a copy of the object, which is less efficient, but it means that your copy is going to persist even when the original has gone, and the copy is being made when we do this assignment here. Now we can't iterate through the stack. Let's just comment this out, and let's just rearrange this. And so that's the wrong code that we don't want to use. And I just want to keep you reminded of that. So let's say here, this is invalid code. Object is destroyed. Okay, so we can't pop it. We can't pop a reference and then carry on using the reference. Reference refers to destroyed object. I really want to emphasize this point because it's very important, because your compiler won't spot it. It will still compile, and often your program will still appear to work, but it's going to end up with intermittent bugs, and they're the most difficult type to fix, and C++ is plagued by intermittent bugs, so you really have to be hyper aware of this kind of thing. Now what we could do is we could sort of iterate through the stack, except that the only way to iterate through it is to remove objects from it. So we could use the size method because that tells us how many elements are in the stack. So we could say while test stack dot size here is greater than 0, then let's put the brackets in there. Let's get the top of the stack, I should say. Hard not to get confused with the different terminologies for different methods for different types of STL classes. But anyway, let's call this test, and then let's do test.print. Test.print. So this is going to show us the stack in reverse order to what we added objects to the stack, because we get the last one that we added first. So we're going to go, whoops, what did I do? I did something wrong. Yeah, we're not doing a pop here. So we're getting the top object, we're printing it, and then I want to pop it off. Let's do test.pop. Pop it off the stack. Test stack dot pop. There we go. So now let's try this. So now we're going to we see here, and I'll also comment out this destructor because it's making it look quite confusing. We don't need it anymore. So we've got Sue, John, Mike. So that's Sue, John, Mike. We get the first one that we added. That's the first one. That's at the top of the stack. When we pop it, the one that we added before that gets to the top. And finally, if we pop that, we get the one that we added first. Last in, first out. That's stack, and stacks are very useful in programming in general. And there's also a queue, which is a very similar kind of structure. Let's copy all this, and I'm going to put a kind of visual break in here as well. Paste this in and format it, and let's change this to a queue. I've included the queue header at the top here, so that's included already. Let's call this test queue, Q-U-E-U-E, and copy that, and we're gonna add items to the queue, and then we'll try to go through it like this. Now there are just a few little differences in the methods between queue and stack, and the way it works is also quite different. So a queue, unlike a stack, a queue is actually a first in, first out structure. So you can think of a queue in a supermarket at the cash register. The first person to enter the queue is the first person to leave the queue. It's first in, first out. With a queue, again, we can push items onto the queue. We can pop them off the queue, and that's going to remove an item from the front of the queue. So it's not the top of the stack, it's the front of the queue. And you have to kind of visualize a queue in your mind. If you visualize the queue from left to right, so people are queuing and the first person to arrive in the queue is at the left, and then people arrive on the right hand side. We're going to go to the front of the queue here, so we can't use top here, we have to use front, and that's going to be the person queuing on the left hand side, the first person who entered the queue. We don't want test stack down there either, we want test queue. So we've got test queue there, this is also test queue, and this is test queue, so they're all right. Let's build this and see if it works. So let's run this now, and now what we see is with the stack we had Sue, John, Mike, it's last in, first out. With the queue it's first in, first out, Mike, John, Sue. So that's the actual order that we added them in. So the first guy to enter the queue, he's the first one that gets popped off the queue. And instead of using top, instead of having the top of a stack, we've got the front of a queue. You can also look at the back of a queue, for example. We could say, not see out, we could say test QUEUE, get the back of the queue there, and that's going to be a test object. We know that, well, rather a reference to a test object. We've created this test class up here. So we can now call a print method on that directly if we want to. So let's call print like that. And we can see that the back of the queue is going to be the last person who entered the queue, which is Sue. So let's take a look here, and we see that Sue was the last person to enter the queue. So she's now at the back of the queue. Let's just put a C out in there, because otherwise it's a bit confusing. So there we go. That's it for this tutorial. Well worth practicing this. I won't give you any kind of exercises with this, although you could, if you wanted, again, you could create a menu system and get the user to enter information which you add to a queue, and then try it with a stack as well, and allow the user to remove items from that database and then see how it's different with queue and stack. If you want, you could do that, or just try typing out something like this. Check that it works as you expect, and remember that it's the top of a stack but the front of a queue. Remember that a queue is going to be first in, first out, and a stack is going to be last in, first out. That's the difference between them. And you use push and pop to add elements, and pop doesn't actually return the element, it just removes it and throws it away. You have to use front to get the front of a queue, or top to get the top of a stack. So it's a bit confusing when you just see it in a video, but if you practice that a bit, you'll really quickly get the hang of it. This is not that complicated. You just need to type it out a bit and practice it, and make mistakes, and then see what you've done wrong, and gradually it will sink into your head. So well worth practicing this. Just try using a queue and a stack, and it's worth trying to see if you can figure out how to iterate through it just from memory, just after watching this video. And if you can't, if you refer back to the video, then try it with the other collection. If you started with stack, then try queue, and then see if you can do that from memory, because it's very, very similar to iterate through it. And remember, we have to remove the objects one by one to iterate through this, so it's not really iterating through it, it's actually removing them one by one and then just looking at what's at the top or the front. So if you do that with one of these collections, then you're in with a fighting chance of being able to do it from memory for the other collection. So that's also good practice if you want to try it. So that's it for this time. Until next time, happy coding.